Hello all, welcome to Code Hub. Today let us solve the Lead Code's daily challenge, and the problem is find median from data stream. The median is the middle value in an ordered integer list. If the size of the list is even, there is no middle value and the median is the mean of the two middle values. So if there is 1, 2, 3, 4, then the median for this is nothing but 2 plus 3 divided by 2, which is nothing but 2.5 something. 2.5 something. If there is a odd number of values, then the median is nothing but their center value, middle value, which is 3. So this is how we are going to find the median. So what we want to do is this add num is going to add the number in our stream. And this whenever this find median is called, we have to say the median with the current elements that we have in our stream of elements. So basically that is our problem. So actually what we can do is we can maintain a vector, and for each and every time when we are adding the element, we can just sort them, and whenever the find median is called, we can just take the center two elements and then give, if it is an if it is an even number of elements, else we can give the center element if it contains odd number of elements. But this is not that much efficient, because the constraint is the at most 5 into 10 power 4 calls will be made to add them and find median. So if it is so, 5 into 10 power 4 calls is made, then each and every time add num will going to sort the array. That will take an n log n time complexity, and yeah, and this is going to be 10 power 4. So it is going to be 10 power 4 into n log n, which is nothing but it will become more than 10 power 8, and it may grow up to n square log n. And this find median is not that much, it is going to be a simple order of 1, but here this add num is very costly. It is going to be a quadratic solution. So can we optimize this solution? Definitely yes. We can optimize the solution using a priority queue. Uh, Here we are going to say priority queue as priority queue is nothing but we are going to have a max heap as well as the min heap. Why is that so? As you can see that we are this element should be in sorted order to find the median. So for each and every time we need to sort the entire array once the number a new number is added. So instead what we can do is we can maintain a max heap for for right half, sorry, left half. As you can see, this 1 2 3 is increasing, so we can just maintain a max heap so that the 3 is on the top of the priority queue, and we can maintain a min heap for the right half in the sense, you can see this 5 4 3, it is decreasing from 5, it is going to be decreasing. So we can just maintain a min heap so that 3 is in the top. So if we maintain this max heap and min heap, like if we can just consider we have a set of elements 1 2 3 4 5, and we can also have a 6. So if we can maintain a min heap, max heap into the left half, then this is nothing but 3 2 1, this is going to be our max heap. And we can also have a min heap which is nothing but 4 5 6. This is our min heap, right? This is a min heap, this is a one max heap. I think I can represent you, and so hope this is making sense. So consider this is a max heap, and this right half is stored in a min heap. As you can see that to find the median, we can see the size of both max heap and min heap. Whenever the size is equal, it is proven that this max heap is going to contain the first half, and this min heap is going to contain the for second half. So that is nothing but, if two heap size is same, then it contains even number of elements. So how can we find this median? Median is nothing but the max heap dot top plus our min heap dot top, and it is divided by 2, right? Yeah, I hope it is making sense. So whenever the two heap size is same, even the number of elements, so to find the median, it is nothing but the max heap top and min heap top divided by 2. So whenever there are odd number of elements, that is, consider we are having something like this 4, and consider we can eliminate this, or let us say we can just eliminate this. So this stream is containing a odd number of elements. As you can see that the set of elements here is 1 2 3 5 6, and I have moved first 3 elements to max heap and the last 2 elements to the min heap. So if we are having an odd number of elements, I am always maintaining, if odd number of elements, I'm going to maintain one element extra in max heap than min heap. I think I'm making sense. As you can see that the one element is the number of elements is 3 in max heap and the number of elements is 2 in the min heap. So I'm going to maintain one element extra than the max heap and the min heap. So that how we can find the median? So median is nothing but, if size is different, then obviously the median is nothing but my max heap dot top. This is what we are proposing. So but how we are going to check whether this how we can say which element to put in our max heap and which element to put in our min heap? Just we can analyze that, how we can do that. So let us say I have 1 in my max heap. I have 1 in my stream, that is the add num function is called with the element 1. So I'm seeing the max heap is empty. Initially the max heap is empty, so I can just put 1 into my max heap. So I can just put 1 in my max heap. Consider we are having now 5 to our stream. So once the 5 is added, we have to check whether it is in max heap, or whether it should be put in max heap or it should be put in min heap. So we are having two conditions. If my max dot size is equal to my min dot size, max and min is nothing but the max heap and min heap. So if my max heap size is equal to min heap size, then obviously I want to check the current element, the added element to the min heap. But we can see that the max heap size is not equal to min heap size. The min heap is 0 now. The number of elements is min heap is 0 and in max heap is 1. So obviously I want to decide this 5 to put in max heap or min heap. So if my max heap size is not equal to min heap size, what I'm going to check is if my current element is lesser than my max heap dot top. If my current element is lesser than my max heap dot top, then what should I do? Consider we are adding a 0 here. If it is a 0, then 0 is lesser than this max heap dot top. So obviously what I should do is I should put min heap dot push of max dot top, and then I should pop the max dot top. So this 1 will be moved to min heap and 1 is popped out from the max heap and 0 is pushed into our min heap, into our max heap. So max dot push of current. So this is what we will be doing if my current is lesser than max dot top. What if my current is greater than max dot top? Let us consider we are inserting a 5 here. So previously there is a 1 in our max heap. So let us observe now. As you can see that max dot size and min heap dot size is not equal. Since it is not equal and the current element that should be added to our priority queues is nothing but 5. So since 5 is added, 5 we are seeing that 5 is 5 is lesser than this max dot top. Since 5 is not lesser than max dot top, 5 is greater than 1. So we can just have an else part. What we can do is we can just push that 1 into our min heap. So min heap dot push of current. So as simple as that. If my max heap dot size is not equal to min heap dot size, this is what the case that we are going to handle. So now let us try to check the similar stuff when it is equal. Consider we are having an equal number of elements in both max heap and min heap. As you can see that max heap and min heap is having equal number of elements, and consider we are having an element which is going to be added, which is going to add is nothing but 6. As you can see that 6 is going to be added to our stream. Once the 6 is added, we are checking the size of min heap and max heap. It is equal to equal. We are both priority queues containing one number of elements. So we are want to decide to put 6 in min heap or max heap. So since it is equal, we want to check whether we can put that current element to our min heap, so that we can just pop that top element and put it to our max heap, then push our current element to min heap. If at all we cannot put that, we want to check whether we can put that current element to our max heap itself. So how we can check is, we can check if my current element is lesser than min heap dot top. As you can see that 6 is not lesser than min heap. Let us take an example like 4. We want to insert this 4 to our stream. Since 4 is lesser than min heap dot top, as you can see that 4 is lesser than min heap dot top, you can assume that 4 should be put inside uh, don't confused. If 4 is lesser than min heap dot top, obviously what we can do is we can just put this 4 to our max heap itself. So max dot push of 4, because the sorted array looks like 4 1 4 5. So 1 and 4 should be present in max heap, and this 5 should be present in our min heap. So once the cur is lesser than the min heap dot top, so max dot push of cur. So this is made clear. What if my cur is greater than my min dot top? That is I will give another case. Consider we are having a 6 now. The added element is 6. So we want to decide we should put in min heap or max heap. So since current element is not lesser than the min dot top, 6 is not lesser than min dot top, so we want to move this 5 to our max heap, so that it becomes 1 and 5 in our max heap and 6 in our min heap. So how can we do that? We can just put max dot push of min dot top, and just we can pop that min, and then we can just put min dot push of our current. So this will be clear, right? 6 is added to our min heap. Before that we are just putting our top element of min heap to our max heap. So hope it is making sense. It is very simple, as if you follow my explanation clearly from the first, or else you can see the video once again to get a better understanding. So this is a hard problem. I'm trying to do my best in this editor itself. So let us see what we can do next. So this is the function that we are going to do for add num. So now we have we have completed this add num function. Now let us try to write an algorithm to find the median. So to find the median, what we can do is the similar stuff we are going to do. Based on the max heap dot size and the min heap dot size, we are going to decide we are going to decide. If my max dot size is not equal to min dot size, then what is the case here? My max heap is going to contain something like as 1 2. Then consider we are having a min heap which is going to contain this 3. So if this is the case, if my max dot size is not equal to min dot size, we can directly return the max dot top. That is going to be my median. Because it is containing odd number of elements, so the center element is nothing but the max dot top, since we are maintaining like that. If it is not so, it is an equal number of elements. If it is equal number of elements, we are having an even number of elements, so my median is nothing but median. So int median is nothing but, sorry, double median. It double median is nothing but max dot top plus min dot top divided by 2.0. This is going to make me double. That's why. So we can just return this. Now we can just return median. So it is as simple as that. I hope you are getting. I hope you are actually following my explanation. If it is clear, we can try to code now. So the time complexity here will be an order of n log n. We can. It is not that much costly like the previous brute force approach, which is n square log n. So we are using a priority queue. So what we can do is we can just initialize a priority queue here. We priority queue of min heap and max heap. So basically that is going to contain integer, and this is going to have a max heap. And to initialize a priority queue, it is nothing but priority queue of int, and this is a vector int, and this is a greater int. So this is the syntax for the min heap. So we are having a min heap and max heap initialization. Now let us try to copy paste the algorithm and just do it a code as soon as possible. So let us try to keep here, and we can just comment them, and then we can try to code it. So first what we are checking is if my max heap is empty. If my max heap is empty, what I can do is I can just directly insert my num to my max heap and just return max heap dot push off num and just return. So this is what I can do once I have the max heap is empty. If my max heap is not empty, then there arises two cases. Case one, odd number of elements, that is nothing but max dot size is not equal to min dot size. So this is my case 1. And what is my case 2? Even number of elements, max dot size is equal to min dot size. So this is our second case. So let us try to code our first case. If my max heap dot size is not equals to min heap dot size, then what we are actually checking, if my number is lesser than the max heap dot top, if it is so, then what we are doing is we are just putting min heap dot push of max heap dot top, and we are just popping it out max heap dot pop. Once popped out, we are just inserting max current element to our max heap dot push of the current element num. So we have done that. Now next what we can do, if else what we have to do is we have to just put it in our min heap. So min heap dot push of the current element num. So we are handled the case 1. Let us try to handle our case 2. Else, if it is having equal number of elements, then what we can check is if my number is lesser than min heap dot top, then we can just put our number into our max heap. If you try to trace it in your pen and paper, it will be very it will be great to understand. So if it is not so, then I have to move my move my top element from the min heap. So we can just say max heap dot push of my min heap dot top. So we can just pop from min heap. Once popped it out, we can just insert my min heap dot push of my current element number. So we have handled the two cases. Now let us try to find the median. The median also has the same two cases as before. So we can just try to copy paste this. What is the states if my max heap dot size not equals to min heap dot size, I can just return max heap dot top. That is the one I can do. I can say it as, I can just typecast it to double. If it is equal, then I can just assign max heap double median is nothing but max heap dot top plus min heap dot top divided by 2.0, and finally return this median. So now let us try to run our code. Before that, I will erase the unwanted code here and here as well. Hope it is quite simple now to understand each and every bit. Oh, sorry, there is some typo. Min. Where is the min? I have some here. Okay, here it is. Min heap. It is. Okay, great. It gets accepted. Let us try to submit. Oh, there is only one example. Great. Let us try to submit directly now. Superb, it get accepted. Hope you like the solution, and I think I have made the problem. I have break down the problem into submodules and explained it to your understanding. Let us see in tomorrow's LeetCode Daily Challenge. Until then, bye.